So this is Alex Carl for homework 3 for ECE 579, Principles of Artificial Intelligence, University of Arizona. So this is homework 3 for heuristic search, the 8-puzzle problem with A-star search. So if we look at the code base, so just importing a random module because how I created the 15 states for the 5, 10, and 15 configuration puzzles. If we scroll down really quickly at the very beginning, I want to go to the point of code where I created it. So I generated the solution node, and then using one of the heuristics, I created 15, at least for the 15 move puzzles, just by using a random expansion of children. So I found 5 puzzles that would take in the certain pathways 15 moves to solve. So this is not using any sort of search. This is actually just a random generation 15 levels down. And so I did the same for 10 and 5, which created the input file. So there's one thing to mention that, in the solutions, these were solved quicker, which means that, this heuristic is an admissible heuristic because it took shorter amount of time. No, sorry, the choice of the children took longer than the heuristic because that's what was found in the output file. So for 15, the maximum it took using the heuristics was actually 15 moves, and the minimum time was a lot less. But just going back up, so inheriting the class from the previous homework, so we created a node and then set the specific attributes of the node, of the state, parent, number of displaced tiles, the Manhattan value, which we calculate, and setting g values in children and these heuristic states, of which we have functions 1, 2, and 3. We just named h1, h2, and h3 because that's the way it was calculated here. And so this is actually all done in the previous homeworks. So you could see the last video for that. Again, the get methods for the attributes for the node, and then so this additional function of extract solution where pass self to a temporary and create the solution array, and then while the solution is not at 0, the g value of 0 is not at the goal state. We're extending the solution to have a g value, h Manhattan, and the action and the state of the parent, so we can reverse up from the solution to the actual beginning state. And then we reverse it because we want to go from step 1 to the final step rather than the reverse. So, and we go to the 8-puzzle solver class of this class 8 puzzle, where we pass the node and the heuristic, which was changed for each output, h1, h2, h3, which changed the A-star function to find the node. So initial test just to see if the input is actually the goal, of which we'd say the puzzle is solved, and we'd stop there. And we go down to the order, where we order the frontier based on the heuristic. That was the method that I used to actually sort the frontier. So all the children are put into this frontier, and this frontier established with the 8-puzzle. Then once all those children are there at each step, we sort it based on this heuristic. And so that's what we did here, which is the lambda sort from the Python code base. And then the solve function. And so, while we're not at the goal, we expand the frontier, and then looking over the children. So we want to set this cell frontier h, and this is just the count of how many children there are. And so this if current children is not frontier, because we want to add unnecessary nodes. So this to prevent us from getting into a loop. And then we, so once the frontier is sorted, so we pop off the children that are sorted into the frontier, and then we pop off this front node, because that's the one we're looking for after we order based on the heuristic value. And that basically ends up solving the puzzles. So we keep expanding and popping until we get to expanding, popping expanding, sorting, and popping until we get to our goal. And then once the goal is there, we break this, and then the puzzle is solved. And this only takes a few lines of code until we get to it, and then we're gonna go into the reading and printing. So we're gonna open the input, and then we're gonna read it based on lines, put those into an array, and then we're gonna remove this comma delimiter so we can operate it based on on the integers, right? Convert the strings to integers, and then we append it to this problems, and then we bring those problems into its own array, and then we do all of our actions on that. So the first file, we're gonna order the frontier by our first heuristic, and then this is the writing. So we write problem one, set one, iterating through the first 5 in the input values. We print the initial state with ordering based on H1, and so once we take those initial states, we pass them into our puzzle class based on the line and then the heuristic. We solve those, and then once we solve it, we're going to write the solution and all the appropriate solution values. And so we iterate through this. Once we iterate to 5, we pop to the second one, and then we get to this second grouping, because I just want to state that it's the problem, which is going to be problem 2 set 2. So we're going to get this down to 1. So it goes problem 1 set 1 all the way to 5, and then we go back to 1. So problem 1 set 2. And then that's basically the end of the code base, and because we're solving this 8 puzzle, so we pass the 8 puzzle with the node that we create based on the input into B, and we solve B, which is the current node, and then we extract the solution. Is this to the first output file. The second output file, we change the heuristic too, so we change the sorting, and then going down to problems, initial states 1 through 5, and then 6 through 10, and 11 through 15. So these take 15 steps to solve, 10 steps to solve, or 5 steps to solve based on the random values, these random children we chose. And if you see in the output files that it took a lot less steps once we sort based on the heuristic values to solve the problem. And so that is actually the end of the code.